Hey guys, welcome to this video. We are going to talk about the binomial theorem. So this right here is andymath.com. It's got some notes and some practice problems. So if we look at the notes, there's this complicated formula. You can use that if you want. Here's a formula to find the kth term. And here's Pascal's triangle, which I'll be using that. I don't really use this formula ever. Sometimes I'll use this one and I'll usually use this one, but I'll show you guys how I do these. So let's do number one, a plus b to the fourth. So anytime it's to the fourth power, that means there's going to be 5 terms. So I want the row with 5 terms here. So I'm going to use 1, 4, 6, 4, 1. So that's the first step. For the next step, I like to write the first term 5 times. A. And then I'll write the second term 5 times. B. So then we give them their exponents. So this a is going to be to the fourth, and that's fourth comes from the fact that it's a plus b to the fourth. Then we go down 1 each time. And then we do the same thing here, but this time we're going to start at 0 and go up. So now after I add these up, these are the 5 terms of my binomial expansion. 1a4 b0 is just a to the fourth. 4a cubed b1, so I'm going to say plus 4a cubed b plus, and then 6a squared b squared plus 4a b cubed plus, and then 1 times a0 times b4. A to the 0 is just 1. Anything to the 0 is just 1, so this is just a b to the fourth. And if we check it, this should be the answer to the first one. A to the fourth, 4a cubed b, 6a squared b squared, 4ab cubed, and b to the fourth. So that's the right answer. So that's how to do the first one. I'm going to do another one real quick. So this is number 2. First step has to do with our Pascal's triangle. So I'm just going to make another Pascal's triangle real quick. I'll keep going. 1, 4, 6, 4, 1, and so on. So now, since this is to the third, I want the one that's going to have 4 terms. So that's going to be this row right here. So I'll write 1, 3, 3, 1. And I'm just going to rewrite the A 4 times. That's my first term. And then the 2B, I'm going to write it 4 times, but I'm going to include the 2. And I'm going to put parentheses around it. And now we can do the exponents. So the a gets a 3, a 2, a 1, and a 0. And the second term starts at a 0, 1, 2, and 3. So anything to the 0 just becomes 1, so this goes away. So the first term is just a cubed plus. Then this term is going to become, well, there'll be a 3, an a squared, times the 2 that's right there, times b. And the 3 and the 2 can combine to give us a 6. So we have 6a squared b. And now for the next term, we have the 3 again. This time it's an a to the 1 times, and now this 2 gets squared, so it becomes 4b squared, because the b also gets squared. And we can simplify this to give us 12ab squared. And the last one, the a to the 0 is just 1, and the 1 is just 1. So 2 cubed is 8. So it's 8b cubed, and these are our 4 terms. So we can just write them down. A cubed plus 6a squared b plus 12ab squared plus 8b cubed. And this should be the answer. A cubed plus 6a squared b, and it is the answer. Now let's do one that has a negative in it. We can do this one right here, 3a minus b to the fourth. So since we're doing to the fourth, we want the Pascal's triangle that has 5 terms. So I'm going to make that. And it's going to be this one right here. So it'll be 1, 4, 6, 4, 1. And I rewrite the 3a 5 times. I'm going to put parentheses around it because of the 3. And then the negative b, the minus b, I'm going to call that negative b, and I'm going to put parentheses around that as well, because we want that negative to also get the exponents. Then I just do my descending exponents here. 4, 3, 2, 1, 0. And this one's going to be ascending starting at 0. And now we can simplify what each of these terms turns into. Negative b to the 0 is just 1, and this is just 1. So this is going to be basically 3 to the 4th, a to the 4th, and 3 to the 4th is 81. You can use a calculator or just do 3 times 3 times 3 times 3. But this gives us 81a to the 4th. So that's the first term. The next term is going to be 4 times whatever 3 cubed is, a cubed times negative b. Because negative to the 1 is still negative, and then b would just be b. Now I can simplify this. 3 cubed is 27 times 4 is 108, and it's going to be negative 108 because of this negative right here. So once again, that was 4 times 27 times negative 1. Give us negative 108, and then we're left with an a cubed and a b, and that's the second term. Now we do the next term. Bring the 6 over, times 3 squared times a squared, and then this negative squared becomes positive, so it goes away. So it's just going to be times b squared, and that can simplify. 3 squared is 9 times 6 is 54, so we have 54 a squared b squared. That's the third term. 2 more terms to go. For the fourth term, it's a 4 here from the Pascal's triangle. And then we have times 3 to the 1, a to the 1, times, and then a negative cubed goes negative, positive, negative, so it's negative again. I'll just call that a negative 1. And then we have b cubed. And we can simplify that. 4 times 3 is 12, times negative 1 is negative 12, a and b cubed. And now the last one, 1 is just 1, 3a to the 0 is just 1, negative to the 4th would become positive again, so the last term is just b to the 4th, positive b to the 4th. So now we can just rewrite all these terms. It's 81 a to the 4th minus 108 a cubed b plus 54 a squared b squared minus 12 ab cubed plus b to the 4th. And that should be our answer. And we got that by doing all this work up here. And the way we did this work was we wrote down Pascal's triangle, the corresponding row. Then we just rewrote all of our first term, all of our second term, and then did descending exponents, ascending exponents, and then cleaned it up. And we can check this answer. So that was number 4. We just did 3a minus b to the 4th, and we can check it. And we have the same answer. So that's how to do it. And then to find the exact term number is when you would use these other notes. This kth term one. I'll probably make a different video for that. And if you want to practice more, I did 3 of them and there's 3 other ones you can try. So if this makes sense, please like and subscribe. Check out andymath.com if you want to do anything else for math. There's a whole front page here. And you can choose your class or just find whatever you're working on. There's tons and tons of topics. And you can also just search for it here. Like this was binomial. So if you just type binomial theorem, this is everything related to binomial theorem. And that's the page right there. That's it. I'll talk to you guys later. Bye.